Algebra 2, Chapter 4, Section 6. In this lesson, we're going to learn how to find and evaluate the determinants of 3 by 3 matrices, and we're also going to learn how to use inverse matrices in solving equations. Okay? First thing, we're just going to talk through some of this, and then we're going to go through examples. Well, we're not going to worry about how the book shows you how to find the determinant of a 3 by 3 matrix. We're going to worry about the way I think it's easiest to do. Okay, if you remember in a 2 by 2 matrix, all right, we had A, B, C, and D, and it was just a cross multiplication. It was the product of AD minus the product of CB, okay? Same concept in a 3 by 3 matrix. Okay, first thing we're going to do is we're going to rewrite the first two columns, column 1 and column 2 of our right next to our 3 by 3 matrix. And then we're going to take the three diagonals, A1, B2, and C3, the way it's labeled. We're going to take those three diagonals. We're going to multiply those three together. We're going to find the product of each diagonal, and then we're going to add those together. So I'm going to have the product of A1, B2, and C3 plus the product of B1, C2, A3 plus the product of C1, A2, B3. We're going to sum those up, and then we're going to subtract the sum of the products of the diagonals going the other way. So we're going to sum those up, and then we're going to subtract the products of A3, B2, and C1 plus the product of B3, C2, A1 plus the product of C3, A2, B1. All right, so we're going to have the sum of the products of the diagonals going down and to the right minus the sum of the products of the diagonals going up and to the right. Okay, and that's the determinant. We can find the determinant, and all the rules of determinants hold true. Okay, the book shows a different way, but it's a lot of squiggly lines. I don't like it. So find the determinant of matrix F. Okay, so I'm going to rewrite it the matrix over here. The matrix F is this: negative 1, 2, 0, 3, negative 4, 1, 5, 6, negative 1. Okay, there is matrix F. I'm going to rewrite that 5. Step 1, rewrite the first two columns. Negative 1, 2, 0, 3, negative 4, 1. Now you're going to take the products of the diagonals going down. So, what is negative 1 times negative 4 times negative 1? That's negative 4. Okay? Take the product of the next diagonals. 3 times 6 times 0. And add that. So that'd be 0. And then the product of the next diagonal. 5, 2, and 1. What's 5 times 2 times 1? That is 10. So negative 4 plus 0 plus 6 is, negative 4 plus 0 plus 10 is 6. I'm ahead of the game a little bit. Now we're going to subtract the product of the sums of the other diagonals. So start over in the lower left, going up. 0 times negative 4 times 5 is 0, plus 1 times 6 times negative 1 be negative 6. I'm just putting parentheses around it, make it a little easier to keep up with, plus the product of negative 1 times 2 times 3. Well, that's going to be plus negative 6. So minus the sum of those products. So 0 plus negative 6 is negative 12. So 6 minus negative 12 is 18. So the determinant of matrix F is 18. Okay? Let's do a couple more. All right, evaluate this one. Step 1, rewrite first two columns. Negative 3, 2, 0, 4, negative 5, 2. All right, now we're going to take the sum of the products. Okay, so negative 3 times negative 5 times 3. That'd be positive 45, plus the product of the next diagonal, which has a 0 in it, so that's going to be 0, plus the product of the next diagonal. That is 0, because there's a 0 in it. So it's just going to be plus 0, okay, which is just 45. And we know we're going to minus the sum of the next three products, the diagonals, product of the next three diagonals. So that has a 0 in it, so we'll go ahead and add a 0, plus, do the next one, 2 times 1 times negative 3, that'd be negative 6, plus 3 times 2 times 4, which I believe is 24. So it would be 45 minus, if you add those together, it's just going to be 18. So 45 minus 18 is 27. So the determinant of this matrix is 27. Okay, if you think you got it, here's what I want you to do. I want you to pause it here and try this on your own, and then double check the work. Okay, here we go. Step 1. Rewrite the first two columns. And again, this is just to find the determinant. Okay, we're going to take the product of the diagonals. So that's 40 plus, take the product of that diagonal, negative 1 times 2 times 3 is negative 6. And you don't have to put parentheses around it if you don't want. 2 times 0 times negative 6. So that is just going to be 34. And we know we're going to subtract the sum of the products of the diagonals going up and to the right. So what is 3 times 4 times 2? 24, I believe. Negative 6 times 2 times 1, the next diagonal. Negative 6 times 2 times 1, that'd be negative 12. And the next one, 10 times 0 times negative 1 would be 0. So it's going to be 24 minus 12 would be 12, so 34 minus 12. Okay, 34 minus 12 is 22. All right, we're rolling now. Easy stuff. Here we go. Evaluate this one. All right, shortcut. Ding, ding, ding. Pay attention. Take notes. Anytime you have a row or column that's all zeros, it's got to be a row or a column. Diagonals do not count. You don't have to do any math. The determinant is always going to be 0. And if there's determinant is 0, there is no inverse. Remember that. Anytime the determinant equals 0, there's no inverse, regardless of the size of the matrix. All right. Next example. Verifying inverses, okay? Let's talk a little bit. Oop, made it too big. Determine whether the matrices are multiplicative inverses, okay? We learned a while back in the 2 by 2 matrix, there's an identity matrix of a 2 by 2 matrix that has the properties of 1, 0, 0, 1. Okay, and we know if two 2 by 2 matrices, the product equals that, we know they're inverses of each other. All right, for 3 by 3 matrices, the multiplicative inverse is 1, 0, 0, 0, 1, 0, 0, 0, 1. Or the easy way to think about it is the diagonal is 1. Everything else is 0. If the product of two matrices equals that, they're inverses of each other. Okay? So, let's just get to work. So we got to find out if matrix A times matrix B equals an identity matrix. So let's go ahead and get to work. So if you remember, I'm going to make a really big matrix. We won't really need it all, but first row times first column. So 1 times 0 is 0, plus 5 times 0.2 is 1, plus negative 1 times 0 is 0. So you add those three together, you're going to get 1. First row, second column. 1 times 0 is 0. 5 times negative 0.2 is negative 1. Negative 1 times negative 1 is 1. So you add those together, you get 0. Okay, I'm actually going to rewrite those right below so it's a little easier to see. Okay, so I have 1, 0 thus far in my matrix. Okay, first row, third column. 1 times 1 is 1. 5 times 0 is 0. Negative 1 times 1 is negative 1. So 1 plus 0 plus negative 1 is 0. So right now I have the makings of an identity matrix. So we go on. Second row, first column. 1 times 0 is 0. And again, if you see these steps, you don't have to write it all out. 0 times 0 is 0, or 0 times 0.2 is 0. Negative 1 times 0 is 0. So that's a 0. All right. So what does the next one have to be be an identity matrix? That's right. It has to be a 1. So let's see if this happens. 1 times 0 is 0. 0 times negative 2 is 0. And negative 1 times negative 1 is 1. So we are still on base, or on course, to have an identity matrix. Okay? Now, let's go next column. Same row, third column. So here we go. 1 times 1 is 1. 0 times 0 is 0. Negative 1 times 1 is negative 1. So you sum those up, you get 0. So we are still on course for an identity matrix. So we got 1, 0, 0, 0, 1, 0. So the third one we need to be an identity matrix is 0, 0, 1. So let's see. Now we go third row, first column. 1 times, before we start, let's see something. What do we notice about that number and that number? They're both zeros. So when we multiply, we're going to notice it's just going to be the first column. So pay attention as I go through this a little bit quicker. 1 times 0 is 0. 0 times 0.2 is 0. 0 times 0 is 0. So that's just 0. 1 times 0 is 0. And see, these two are going to be 0. So it's going to be 0 plus 0 plus 0. So that one's going to be 0. Last one. 1 times 1 is 1. 0 times 0 is 0. And 0 times 1 is 0. So it's going to be 1. So yes, they're identity matrix. So the answer is yes. They are inverses of each other. All right, next example. We got to determine whether the next two are identity matrices. Same process, okay? It might be a little tedious, but you understand. Step 1, first row times first column. All right, 3 times 0 is 0. 4 times 1 is 4, and 1 times 0 is 0. So 0 plus 4 plus 0 is 4. All right, does that have the makings of an identity matrix? Absolutely not. An identity matrix looks like this. So do I need to do any more work? No. Not inverses. If it doesn't look exactly like it, it doesn't work. They're not inverses. All right, so that's today's lesson, talking about finding the determinants of 3 by 3 matrices and finding out whether two 3 by 3 matrices are inverses of each other. Okay? When we get back, we'll go continue our lesson on matrices.